Emostel.
Welcome to class. In this video, we are going to be solving a couple of questions to master the things we learned in the previous video. All right, so ride along with me. Now, in this example, we have a vector A and vector B. Vector A is this value, vector B is this value. And the question says find A dot B, find B dot A. So we just want to use this question to prove the law of commutativity of vectors and then of scalar product of vectors. And then also, I didn't even tell you the reason. I told you the last point of the previous video says that no matter how much you do it, the result of a scalar product is always a number. If, as a matter of fact, that is the reason why it is called scalar product, because it's the product of two vectors that always produce a number instead of producing a vector. Do you understand? Unlike its vector product, that one, when you carry out the multiplication, it will lead to another vector. So when two vectors cross each other, the end result is still a vector for cross product. That is the other one we will do after this. But for this one, the dot product is always a number, and that's the reason why they call it a dot product, or they call it a scalar product, because the result is always scalar, not a vector. All right, so we have this A dot B, so let's quickly run it. Now, we know vector A is this, vector B is this. As you can see, this is the x component for vector A. The x component for vector B is 1. Since no number is written here, then it means it is 1, invisible 1. All right, so the y component for this is not just 3, but minus 3. And then the y component for this one is positive 1. The z component for vector A is 1, because there is nothing written here. And then the z component for vector B is 2. So remember that formula, the formula which says that A dot B is going to be equal to the x components of the first vector, x1, x2, then plus what? y1, y2, plus z1, z2. So we are going to just apply those dots. So we are going to say 2 times 1, that's 2 times 1, plus minus 3 times 1, okay, plus this 1 here times 2. Okay, so that's what we're going to do. Remember, this is x, y, and z. All right, so when we have it that way, so we have 2 times 1, which is 2, all right, plus minus 3 times 1 will give us minus 3, because minus times plus is minus. Then 3 times 1 is 3. Then plus 1 times 2, which is 2. So since this one is not negative, I can expose it. I kept this one in the bracket because we still need to carry out something to simplify further. But for positive number, you don't need that stress. So we have 2. Now plus times minus is minus. Okay, then we open the bracket, 3 plus 2. You don't just jump into, remember, just take notes. The same caution, I'm always extra careful with signs, because as little as the sign is, it can disrupt the answer. You won't be able to get the correct answer again. So we have this, A dot B is minus 2, 2 minus 3 plus 2. Okay, so 2 plus 2 is 4, 4 minus 3 is 1. So we have A dot B, that is the dot product of vector A and B, is 1. Get that? So now let's try and see what is going to happen if we do B dot A. So when you do B dot A, you have x1, x2, because B is coming first. So we are going to have the stuff for B coming first. So that's going to be like x2, x1 plus y2, y1 plus z2, z1. For obvious reason, you see that you're still going to get the same answer, because 2 times 1 is the same result as 1 times 2. So no difference, okay? So that's exactly what's going to happen here. So, we having 2 times 1 here before, because this is 2 and this is 1. It's now going to be 1 times 2. So 1 multiplied by 2, okay, plus 1 times minus 3, then plus 2 times 1. At the end of it all, we have 2 plus 1 times minus 3, that's negative 3, then plus 2. So which is 2 plus times minus is minus 3 plus 2, and you still end up getting the same answer. So B dot A is equal to 1, as you can see. Okay, now the next question says find the angle between A and B, and this is where the long thing lies, because before you can find the angle between 2 vectors, you need to find the magnitude of each of the 2 vectors. So since we have, the formula says, the dot product formula, so trying to solve the third question, the dot product formula states that A dot B is equal to magnitude of vector A multiplied by magnitude of vector B cos theta. So this angle theta is what we are looking for. So in that case, we can make the theta to be the subject of the formula. So we say cos theta is equal to A dot B divided by the magnitude of A and divided by the magnitude of B. So we solve this part first, then we take the arc cosine of that part. So now we already have the dot product of A and B, which is 1 in both cases, which is 1. Okay, now the thing we need to find now is the magnitude of vector A and the magnitude of vector B. So the moment we get the magnitude of the 2 vectors, we bring it back into this formula, put all the other parameters, and then we move on to finding the angle. All right, so let's quickly do that. The magnitude of vector A is going to be the square root. We've done this before, right? We know about this. So the magnitude of vector A is going to be the square root of the components of vector A, the square root of the sum of the squares of the components of vector A. So what are the components of vector A? The x component is 2, so we say 2 squared, plus the y component is minus 3, we say minus 3 squared, say plus the z component is 1, say 1 squared. All right, so as we have it that way, then we are going to have the square root of 2 squared is 4, then plus minus 3 squared, that's 9. Minus 3 squared means minus 3 times minus 3. So the minus times minus is positive, then 3 times 3 is 9. So we have positive 9. Plus times plus is plus. So then we have 1 squared, which is 1. At the end of the day, the magnitude of vector A is 4 plus 9 plus 1. And then that is the square root of 14. The square root of 14. That is the magnitude of vector A. Then the next thing is to find the magnitude of vector B. The magnitude of vector B is going to be equal to the square root of the sum of the squares of the components of vector B. So what are the components of vector B? We have 1 squared, then plus another 1 squared, plus here 2 squared. Okay, having that will be 1 plus 1. 1 raised to power 2 is 1. 1 times 1 again is 1. And 2 times 2 is 4. That's 2 raised to power 2 means 2 times 2. 2 in 2 places. So, all right, then 1 plus 1 is 2. 2 plus 4 is 6. So we have the square root of 6 as the magnitude of B. Now that we have the magnitude A, we have magnitude B, and we already knew that the dot product of A and B is 1. we can proceed to finding the angle. All right, so let's find the angle between A and B. So we say cos theta is equal to what? A dot B over magnitude A times magnitude B. So, which means cos theta is the angle we are looking for, is equal to A dot B, which we earlier got as 1. The magnitude A is the square root of 14. The magnitude of B is the square root of 6. All right? So mathematics allows us to multiply the two square roots together. So it simply means 1 over the square root of 14 times 6. Now, that would be the square root of 14 times 6. If you just have your calculator, you can do it straight up. But then let me just do it. 6 times 4 is 24. We have 4 remaining 2. 6 times 1 is 6 plus 2. That is 8. So we have 84 here. So I need to find the square root of 84. So you have to excuse me, please, so I can use my calculator. Okay, so scientific. All right, the square root of 14 is 3.74. Let's just say 3.7417. Okay, so now this value you just got, you will divide it by 1. Okay, sorry, you divide 1 by that value. And so we have cos theta is equal to the result of this division, that is 1 divided by 3.7417. Good. So 1 divided by that result gives 0.2673. 0.2673. So which means angle theta is going to be arc cosine of 0.2673. What this simply means is that we are looking for the angle whose cosine would have given this value. So we are looking for the angle whose cosine would have given this value. So when cosine or sine or tangent moves, when they leave the angle and they move to the other side, they move to the other side as arc cosine or arc sine or arc tan. You get that? So in your calculator, so just find the value of the arc cosine of 0. This. So I'm going to do that now. So that's going to be the inverse cosine of 0.2673. All right, so the inverse cosine of 0.2673 is 74.5. So we have 74.5 degrees. That is the answer to that question. 74.5 degrees to the nearest to 1 decimal point, the 1 decimal place, sorry. So that is the value of the angle. So we've just finished solving this question. We found the dot product. We were able to verify that dot product is commutative, and then we were also able to find the angle between the two vectors, and that is beautiful. All right, so let's see how to solve the question. Let's see another approach to dot product with example 2. Please, you can practice with more questions on your own, or you check the platform for practice questions. And those who don't have access to our platform, you check Emostel Academy out. Go to our website, see how you can join Emostel Academy to enjoy much more goodies than what you're having here. All right, so there's a whole lot more, so much more to get when you join Emostel Academy. But if you're not a student of Emostel Academy yet, you are really missing. Okay, so now let's just let's move on. In example 2, we have it that vector A is equal to 2i minus yj plus k. So which means this value is unknown. We don't know the value of that component. We don't know the magnitude. All right, and then, but the other ones, okay, this is 4, this is 1j, and then this is minus 5k. But the question says, find the value of y if both vectors are perpendicular. Remember what we mentioned about perpendicular. Recall that for perpendicular vectors, A dot B is always equal to what? 0. You know the reason why? Because cos 90 degrees is 0. So if cos 90 degrees, if two vectors are perpendicular, it means their dot product is 0. All right? Because cos 90 degrees is 0. I've explained that earlier. You can just rewind if you didn't get that part. So now that we know that A dot B is 0, the question already gave us that the two vectors are perpendicular. Then in that case, we are going to find the dot product of these two vectors and equate it to 0. Whatever result we get, we equate the results to 0. Then that should help us to find the value of y. So let's play. Now, A dot B normally is going to be equal to the sum of the products of the components of vectors A and vector B. So let's go. What is the product of components of or the x components? That will be 2 times 4, okay, plus the product of the y components, okay, that will be minus 1, because minus y, then multiply by the y components of the second vector here, which is 1. You know, since they wrote ordinary j, it means 1j, okay? Now, then plus, it's always plus. Then this is, as ordinary k is written here, it means 1k. So you write 1 times the component of z here will be minus 5. Good. And then because A dot B is equal to 0, you equate everything here to 0. A dot B was equal to 0 because the question says the two vectors are perpendicular. So as you have it that way, you are going to then say 2 times 4. So you have 2 times 4 is 8, plus minus y times 1 gives us minus y, then plus 1 times minus 5 gives us minus 5 equals 0. You should notice that whenever I'm solving a question the result is negative from the bracket, I still retain the negative result. But if it is positive, we just leave it the way. Reason why the negative result is always retained, still in the bracket, is because you still need to take one more step of opening the bracket by multiplying the negative number with the sign that is outside of the bracket. So that's what we are going to do now. So we have 8 plus times minus is minus. Then you write y is free. Then plus times minus here again is also minus. Okay, then everything is equal to 0. You should remember that when the same sign multiply, the result is always positive. But when different signs multiply, the result is always negative. Okay? All right, so then we have it 8 minus y minus 5. So since y is what we are looking for, we send everything else to the other side. So we have minus y is equal to 0 that was here before. Then this 5, it was negative. By the time it crosses to the other side, it becomes positive. Then this 8 was positive. By the time it gets to the other side, it becomes negative. And so you have minus y is equal to 0 plus 5 minus 8. So which means I'm having 5, but I'm owing 8. So if I pay the 5, okay, I will still be owing 3. So at the end of the day, minus y is equal to minus 3. Mathematics permits us to cancel out on both sides. So y is equal to 3 at the end of the day. So the y that the question wants us to find, eventually the value of y is 3. So simple. You see that nothing is difficult in mathematics. The only thing is for you to just be accustomed to, just understand the rules, and then the rest is left to your initiative. Mathematics is one of the subjects that is used to test students' IQ. And that is the reason why, in my own opinion, that is one of the reasons why they would say that before you can apply for a law program, even law, there are many programs that you want to apply to that may not necessarily need a lot of mathematics. In fact, it's like little or zero mathematics. As a lawyer, I don't think you're even solving any maths in university. Okay, maybe in one of your economics courses anyway, you might be solving maths, but there are some courses that you might not even have any business to do with maths, but yet you must pass maths before you can gain admission into that school. What do you think? What message does that pass? Mathematics is one. It shows that for you to pass mathematics, it means you are intelligent. It means you have some good level of intelligence in you. So mathematics, apart from being used to solve questions, one of the advantages one of the thing about it is that it is used to test your intelligence. And then if you get accustomed to maths so much, naturally your intelligence quotient grows. All right, so let's just move on. Let's call it a wrap for this topic, and then we'll move on to vector products in the next video. Take care. Bye.